Is our group design project for Mean 1000, Connor, Sam, and Jacob. At the beginning of the semester, we were tasked with designing and building a robot that could complete two tasks. The first task was to have our robot go through a course with obstacles of unknown location to find a black square on the ground, and also in an unknown location within 2 minutes. To do this, we would need to use a closed loop or feedback controlled code in combination with any sensors we decide to use. We would need to place our robot anywhere in the course, start it, and have it find and stop on the black square. The second task was to have our robot go through a course with obstacles of known location to find a black square also of known location. To do this, we could use an open loop in combination with any sensors needed. As easy as it sounds, we had some constraints to consider while trying to reach our objectives. Our main constraints were needing at least two parts made using prototype equipment. We decided to use a 3D printer. Our robot needed to be able to go over ramps. It needed to navigate the course without getting stuck. Lastly, it needed to find the black dot and stop on it. These were our non-negotiable constraints. Our objectives included, but were not limited to, completing it in less than 2 minutes, as fast as possible, avoiding collisions, minimizing extra cost, a simplified design, and a durable design. Now that we had clarified what we were going to do, we needed to decide on how we were going to do it. So we met up, we started brainstorming on our design functions. At its core, our robot needed to be able to find and stop on black square, avoid obstacles, and be able to move over ramps. There are many ways to accomplish these tasks. We just came up with a few and worked from there. During our next meeting, we went over many different designs and we started drawing them up and weighing the pros and cons. Our first designs were wheeled robots because that's where our mind went for first, and we had differing sensors on them. Some had pressure sensors, ultrasonic sensors, and color sensors. We discussed having one motor controlling a single axle versus having two motors, each controlling a wheel. We also discussed whether or not we wanted to design a steering function or if we could possibly control steering with distributing different amount of power to different wheels. One of the main concerns that came to mind with wheels was the ramps. Would we have to power the front and the back wheels? Would we high center on the ramps? This led us to our next set of designs, which was with tracks. With tracks, we took away some of the questions that we had about wheels. We would have to turn by distribution of power to each side. We could not high center, and we would have improved traction. Our next main question was pressure sensor versus ultrasonic sensor. Although we could do both, it would become more complicated, which went against our objective of having a simple design. So we decided to go with an ultrasonic sensor and the color sensor for the black square. Now that we had our design, we need to start building and testing. So because of this class, almost all of our components we already had in our possession. The one thing we needed was the tracks and the base to build off of. And we started looking at different options to do that, whether we wanted to 3D print it, buy the tracks from a different company. And through this research, we found a base chassis with tracks that had two motors on it. Something that was, I think, designed for something similar to what we were doing. So we decided to purchase that, which was our one cost we had on this project besides our time and some 3D printing filament, and we built it up from there. So we ordered the tracks and the chassis and waited for it to come. It came, but as a lot of things that come in the mail, it was not complete. We were missing a few pieces, which led us to our first 3D printed things that we needed, which were the two wheel bushings, one in the front and one in the back across the motors. that lined up our tracks to keep them straight. So then we moved on to 3D printing a base plate. First, we had to design what the top of our chassis looked like so we could build our base plate on top of that so we knew all our components would fit. So we designed our base plate to fit our Arduino, 2 batteries, and a breadboard, and 3D printed that. And we also designed a mounting piece. Well, we ended up designing 2 mounting pieces to hold the ultrasonic sensor on the front, which also just mounted to that base plate. And that was more than our 2 required 3D printed things we needed. Once we had everything printed, we went on to putting everything onto the robot and testing. So this is what our robot looked with all the components together. A few changes that we made to our original design was the front ultrasonic sensor holder. Instead of going straight forward, we ended up printing it a holder that would hold at an angle, because through trial and error, we realized that our coding that worked, which followed blank spaces, would work better with it pointing to one side. We also used a photoresistor and an LED on the bottom instead of a color sensor. This was part of the cutting cost and a simplistic design part of our project. So this LED would shine on the ground, which was a lighter color in the black square, and then give different readings. We had to calibrate this at the beginning of each run because it would always be a little bit different depending on the light in the room. So to start our first run, we calibrated the photoresistor to make sure we were setting the code correct to detect when we were over the black square on the floor. And after that, we put our robot on the floor on the right bottom side of the arena and pressed our button to start. This run was the unknown placement of obstacles. The black square was at the bottom left side of the arena, so our bot basically had to turn all the way around and find its way to the other side. The way we had our code set up, as I mentioned earlier, was that it was following empty spaces. The ultrasonic sensor would measure the distance that it read from the one side, and if it was too close, it would correct and turn, which you'll see in the video. And then it would keep going straight as long as it didn't detect anything on one side. We ran our robot a few times. The run in this video is our fastest of the many runs we had. We had most successful and a few on. As you can see, that ultrasonic sensor picking up the walls and adjusting. And as it approaches the black square, it picked up the sense and stopped. So for our second run, we had a preset course. With the majority of the obstacles in the center of the course, we opted to have a short burst at the beginning to get over the ramp, and then a steady turn to essentially make a circle that landed on the black square. This took some trial and error to get both motors running at the right speed to land on the black square. We didn't get a perfect run as we ran out of time in the lab, but we did have both components working separately. We just didn't get both things in the same run. So we'll take a look at those videos. So as you can see, we had both separate components working. We didn't get one solid run together. Overall, project was a success. Everything we designed worked well. I think looking back at this project as a whole, I think our planning and troubleshooting at the beginning of the project, we were able to avoid a lot of mistakes that we could have made, which reduced our trial and error and also made this more efficient. There's always room for improvement though, and I think our design possibly could have been a little bit cleaner. We could have designed more components, made it look better, just cooler, I guess, without all the wires. But that's not really necessary for what we were trying to do. We could have made a robot run faster, which would have made the runs even quicker. But then we would have had to tweak the code, and it would have caused just a less simplistic design, which was one of our objectives. One thing I think it could have improved was putting a bumper sensor on the front of our robot, so not only the ultrasonic sensor would also have a pressure sensor to change direction if it needed to. Besides that, everything was a success.